Hello everyone, hi. Just gonna get some music playing here. Let's see. What about this one? Okay, I'm just gonna give it a few minutes so that as many people as possible can join. Please share this live with your friends. We're doing circle geometry today, which is a very highly requested topic. So hopefully, yeah, this will help you guys. Thank you for sharing. Thanks so much. Let's see, what's the time now? 2:31. I think we'll start at 2:34. So I'm just gonna write that here in case people join. So we are starting at 2:34. Right, so go grab maybe some water, something to eat, snack on, something to drink while we're busy. I'm also actually going to go get myself some water quickly. And please keep sharing, guys, so that as many people as possible can be on this live and can learn from this. This is by far the most requested topic, circle geometry. Everyone wants to do circle geometry. Yes, people are on holiday, but it's the perfect time to learn something as well. But if you would rather be on holiday, that's fine. I won't feel offended. Thank you for sharing, guys. I'm going to be back in a minute. I'm just going to go get some water. Oh, sorry, I kicked the ring light. Let me just fix that. There we go. I'll turn the music up a bit so that you can hear it. There we go. Okay, there are 59 people. Hello everyone. I just went to go get some water. We are starting in 1 minute. Please keep sharing. I see there are 5 shares so far. Please keep sharing. I'm going to start at 2:34, so we're almost there. Thank you for all the likes, guys. How lovely. Yes, I will save them. So I've actually already posted yesterday's live to my YouTube. I posted it last night. And then I also posted the notes that I took during yesterday's live. They are also on my Google Drive. I made a new folder which I haven't linked in my link tree yet, but if you just go to the main maths folder, there is a folder called TikTok Lives and the notes are in there. But yes, I will link that in my link tree afterwards so that you can just go click there. Okay, yes, Kaylee, thank you for reminding us. It is time. Okay, guys. So if you were on yesterday's live, then welcome back. If you weren't, then I'm so glad that you've joined us for the first time. My YouTube is Miss Honeycomb. If you click the link in my bio, you can just scroll down until where it says YouTube, and then you'll find it there as well. I'm almost on 3,000 subscribers, guys. I need 10 more to be on 3K, so that would be fantastic. If 10 of you can go and subscribe, I would really appreciate that. Then we are on 3,000 subscribers. All right, guys, we're going to get going. So yesterday, I'll just show you quickly what we did yesterday. Like I said, this note is on my Google Drive. We did the November 2021 questions on circle geometry. So this was the first one that we did. Then that was question 9. We then did question 10. Then we moved on to the May-June 2021 paper, and we did the first circle geometry question on there, question 8. We are now going to move on to, well, that was actually 8.1 we did yesterday. We're now going to move on to 8.2. So someone's asking for financial maths. All my financial maths videos for grade 12 are from last year, are already on my YouTube. You just need to go through. I actually checked earlier today, and it looked like I hadn't made a playlist for that last year for some reason, but they are on there. You can just you can go to the grade 12 playlist, and I'll try and remember to just make a playlist for finance as well. But I did check this morning. They are actually all on there. Okay, 8.2, guys. So this is the second circle geometry question from last year's SUP exam paper. So in the diagram below, they're saying that A, B, C, D is a cyclic quad. Now, guys, if you were here yesterday, you would have heard me say that it's very important that whenever you are doing these questions, you have to first read through all the information that they gave you and fill in things if you can, all right? While you're reading through it, try and fill in as many values, as many properties that you can actually see, because then that will make answering the question much easier. All right, so they're saying A, B, C, D is a cyclic quad. So I've just highlighted that. I find it quite useful to do that because often there's a lot going on in a diagram and you might miss some cyclic quads. So if you see that that's a cyclic quad, it's nice to highlight it. A, B, and D, C are produced. All right, now when they say that it's produced, that just means that these straight lines are lengthened to meet at point E. Then they're saying AD, which is that one, and BC are produced, so both of these are lengthened to meet at F. Next up, they're saying that angle AFB is 2x. They filled that in on the diagram. Angle DAB is 3x. That is also filled in. And AED is equal to x. Okay, now this is a 6-mark question, guys. One question for 8.2. Determine, giving reasons, the value of x. Now, guys, this is quite an open-ended question. As you can see, they haven't split it up into like 8.2.1, 8.2.2. They actually have just said, they've given you some information and they're saying, determine the value of x. All right. So in this case, what I would suggest is to look at the diagram, and firstly, they've told us that ABCD is a cyclic quad. Guys, they won't give us that information if we are not supposed to use it somehow. So that is probably what I would start with. I would look at, okay, since ABCD is a cyclic quad, which values can I actually get from that, right? What do we know about a cyclic quad? Hopefully we can see that in this cyclic quad we have some exterior angles, right? So C1, for example, is an exterior angle of the cyclic quad. Remember, what makes it an exterior angle? If a side of the quad has been lengthened and then it's on the outside. So C1, for example, is an exterior angle of that cyclic quad, all right? And C1 is going to be equal to angle A. The exterior angle of a cyclic quad is equal to the opposite interior angle. But in the same breath, C3 is actually also an exterior angle of the cyclic quad. If I just cover that bit up, right? C3 is also an exterior angle of the cyclic quad. C3 is also going to be equal to A, right? And we can see that these two angles must be equal because of vertically opposite angles. Now, if I'm looking at this, right? If I'm saying that C3 is equal to A, then I can say, okay, C3 is also 3x. Now, guys, we're working with something here. We need to find the value of x. Okay, they haven't asked us to find the size of a specific angle. They've actually asked us to find the value of x. So is there maybe a way, I'm just looking at this, I'm seeing that I have a triangle here, triangle CDF, right? I have 3x and I have 2x. Can I maybe find what D1 is? Because if I can find what D1 is, then I know this angle plus 3x plus 2x must add up to 180 degrees. And then if I have that, I can solve for x. Okay, I'm going to say that again. 3x is coming from exterior angle of a cyclic quad. I'm actually going to write that down. C3 is equal to 3x exterior angle of cyclic quad. And this is just one way of doing it. There were actually lots of possible solutions for this question. So if you didn't do it in the way that I'm doing it now, that's perfectly fine, as long as we get to the same value of x in the end. That's all that really matters. So C3 is 3x because of exterior angle of a cyclic quad. So now I'm saying we have that angle, we have 2x. If I can find D1, then I can say 3x plus 2x plus whatever D1 is will equal to 180 degrees. All right, now guys, let's look at D1. I want us to look at this big triangle here. Triangle ADE. All right, let's all look at triangle ADE. Do we notice that we have the two interior angles of this triangle, and D1 is the exterior angle of that triangle, right? D1 is the exterior angle of this triangle, and we know that the exterior angle of a triangle is equal to the sum of the opposite interior angles. All right, someone's saying that D1 is 3x, not in this case. Okay, I think you're saying that D1 is 3x because you are saying that these two angles have to be equal, but we don't know that these two sides are equal. All right, we could only say that D1 must be equal to 3x because, or if we know that these two lines are equal, okay, and we don't know that in this case. All right, so D1 is equal to the sum, the exterior angle is equal to the sum of the opposite interior angles. So D1 is going to be x plus 3x, which is in fact 4x. Yes, someone's saying that. All right, so D1 is equal to 4x exterior angle of triangle. And guys, if you want to, if it's easier for you to keep track of what you're actually doing, what triangle you're working in, you can say in your reason triangle ADE. Okay, you don't have to, you won't lose marks if you don't say which triangle you're working in, but it's quite useful if you want to maybe check your work at the end, if you have time to check it. If you actually write down which triangle you're working in, then it's easy to see, oh, triangle ADE is that one over there. Okay, so now guys, that's great because now I have all three angles in this triangle in terms of x, and I know that the three angles of a triangle must add up to 180 degrees. So now I'm going to say, therefore, 3x plus 4x plus 2x is equal to 180 degrees. And the reason for that is angle sum in triangle. Or sum of interior angles. Yes, correct. So 3x plus 4x is 7x plus 2x is 9x. So 9x is equal to 180 degrees. So now if we need to solve for x, we're going to say 180 divided by 9, which is 20 degrees. Okay, so like I said, there were lots of other ways in which you could have done this. As long as you're getting that x is equal to 20, it's fine. And guys, please, as long as you put all of your reasons down. So I think since this was a 6-mark question, they probably, I haven't looked at the memo, but they probably would have given you a mark for that, a mark for the reason, a mark for that, a mark for the reason, a mark for this statement and reason, probably together, and then a mark for the final answer. That's what I think. That's the mark allocation that I think they would have used to make up the 6 marks. All right, so this was a bit of a strange question. They don't usually ask questions like this where you have to solve for x, right? Usually you have to find specific angles and so on, but this was a different type of question. Okay, I hope that that makes sense. Okay, let's look at the next one. This was 9.2. I've left out 9.1 because it was just a proof. So you can go look at that proof if you want to. You can look at the memo if you want to see how they mark it. But I'm not going to go through proofs now because that's basically bookwork. I want us to look at the actual, the hard stuff. Okay, so 9.2. You can see that there's a lot going on in this diagram. So it's very important that we read through this whole paragraph, we annotate this diagram, we write down whatever they've given us, we make sure that everything that's written here is actually indicated here and that we know what we're working with. So guys, you also mustn't just like skim through this. You really have to pay attention when you're reading this and make sure that you know what each bit of information actually means. So they're saying in the diagram, M is the center of the circle M. Okay, we also used this yesterday. Sorry, we spoke about this yesterday. The fact that they've used an M for the center of the circle is unusual. Usually they use an O, but yeah, we need to just remember that M is the center. A, B, and C are points on the circle such that AC is equal to BC. All right, you can see that they have indicated that. So that's important, guys. We need to therefore know if AC is equal to BC, we can already fill some information in here. We know that that angle A1 is going to be equal to that angle B. Okay, we can fill that in so long. So here, let's see what else they're telling us. PA is a tangent to the circle at A. Okay, that's important. We all know that we have tangent stuff, all right, tangent theorem. So PA is a tangent. Now, guys, if we know our tangent rules, tangent theorems, then we'll know that if PA is a tangent, we can use tan chord theorem here, right? So tan chord theorem, remember, says that the angle between a tangent and a chord, so that would be A2, is equal to the angle subtended by that same chord in the alternate segment, so on the other side of that chord. So this angle here. So guys, that actually means I've used a dot to indicate B, right? But A2 is also equal to B. So I can actually use a dot in A2 as well, all right? So these angles are actually all equal. Now see, I've already figured that out without even reading the questions, just looking through the information that they've given us. Okay, PQ is drawn parallel to CA. PQ is drawn parallel to CA. Now guys, that is very important. I'm actually going to highlight that as well. A lot of people miss this, right? Because, I don't know, parallel lines seems like such a like junior grade thing. But if they are giving you parallel lines, you are definitely going to have to use them. Okay, they won't give you, sorry, it's difficult to draw a straight line. There we go. They won't give you parallel lines if you are not meant to use them. Okay, so that's very important. That's why I've actually highlighted those. Now, guys, we can see, right, if I've highlighted those, hopefully we can immediately identify a Z shape over here. Right? Do we remember what we call the Z shape? If we have a Z shape with angles, we call those alternate angles. And if alternate angles lie between parallel lines like we have here, they are equal. So guys, there we have yet another angle that is equal to these three, right? A2 is going to be equal to angle P because of alternate angles, because of that Z shape that we see there. All right, so guys, do we see we've actually already identified so many equal angles here just by reading through each piece of information, slowing down and asking ourselves, what does that actually mean? What is the consequence of the information that they've given us here? And I think most of the time, because you're rushing, I understand obviously you have a lot of stuff to get through in the time that you have to write this exam, but oh sure, that was a gust of wind. What was I saying now? Yeah, I think you guys are often rushing through reading this carefully, and there's actually so much information here, and it's so useful if you just slow down and you take a breath, you go through all this information systematically, and you fill everything in on the diagram. Okay, so they're saying it's drawn parallel to CA to meet BA produced. So BA produced is BA that's been lengthened at Q. Okay, so they're basically saying that PQ and BQ basically meet at Q, which we can see. BC produced, where's BC now? BC produced, so lengthened, meets PQ at R. All right, so they're saying that BR and PQ are intersecting at that point, and AR is drawn. Okay, so they've basically just what's the word? Connected A and R. Let angle Q equal X. All right, so there we have angle Q. All right, so guys, let's take a look at what they are asking us for. Yes, there is another Z. I do see that. All right, we have a Z there with A, 2 and 3 and R, 1. So maybe I should just use a different color here. Let's use a dark blue. A, 2 and 3 and R, 1. Is that the Z that you guys are talking about? That one over there. Yes, we might have to use that. Okay, we'll see. All right, now guys, they are saying in 9.2.1, the first question, determine, giving reasons, 4 other angles each equal to x. Now guys, the fact that they're asking us for 4 angles here that are all equal to the same thing, we already have 4 angles that are equal to each other, right? Now, are these angles also equal to x? Let's take a look. This angle is x, all right? Now, x is an angle that lies here by one of these parallel lines, okay? Now, I'm going to ask you to visualize an F shape. Do we see that? If we're looking at BQ, that's like the back part of the F, all right? BQ is there, BQ, and then the lines of the F are PQ and CA. Let's see if I can highlight that. There is quite a lot going on here now, so this might confuse you. I'll take it away if you... Oh, that jumped a bit. Let me just try that again. Oh, no. Okay, this thing is not cooperating. Oh, dear, sorry. I'll just do it by hand like that. Okay, that's the one line. And then we have CA and we have PQ like that. All right, that's the F shape. I'm hoping you guys can see that. Now, guys, an F shape, those are corresponding angles, right? And angles on the parallel lines here, if corresponding angles lie on parallel lines like they do here, remember PQ is parallel to CA, then they are equal to each other. All right, so this angle X is equal to A1 because of corresponding angles. All right, so there we already have one thing. I'm going to just take away, let me actually remove that F shape there. Okay, I'm going to take away this dot now because now I know that that is actually equal to x. Okay, if that is x, then this is also x because of corresponding angles, because of that F shape. All right, let me just move this down a bit. Okay, we are going to say the first angle is A1. Angle A1 is equal to x. The reason for that is corresponding angles. Angles. Remember, guys, whenever you're using corresponding angles, you have to write which lines are parallel. So PQ is parallel to AC. Okay, you actually lose that mark if you don't write that down. Cool. So A1 is x. Now we need to look at what angle is coming off of A1 is also equal to A1. Remember, we put this in right at the start. We said that B is equal to A1 because this is an isosceles triangle, right? They told us that AC is equal to BC. So B is also going to be equal to X. So that's the next one. And the reason for that, guys, please remember you are not allowed to write isosceles triangle. You have to write angles opposite equal sides. Okay, that is the only reason that they accept when you are working in an isosceles triangle. Okay, angle B. Then, guys, remember that we put this blue dot in A2 as well. And the reason for that is because they said that PA is a tangent. So we worked with tan chord theorem, right? We said that A2 is the angle between the tangent and chord AC, and that angle is going to be equal to the angle subtended by that chord on the other side of the chord. So A2 is also equal to x because of tan chord theorem. Now, I'm hoping that you guys are noticing that every time we get another angle that's equal to x, we're using that angle to get the next one, right? I actually just want to take away this blue line here because it does kind of look like I'm saying that that whole angle is x. Okay, that is x over there. I might fill that blue line in again a bit later if we need it. All right, so let's just do it like that for now. Okay, so we have that angle equal to x. Oh, and then remember we said that P is also equal to A too because of this Z shape that we filled in. All right, because of alternate angles. So that is then the fourth one. Angle P is also equal to x. Alt angles. And then again, you have to put in which lines are parallel. It's the same too. PQ is parallel to AC. All right, perfect. Let me just put that x in there as well. All right, so guys, that was a 6-mark question. So in some cases, they will give 1 mark for the statement and the reason, and in other cases, they give 1 mark for the statement, which is saying like which angle it is, and then a separate mark for the reason. So I'm not entirely sure which one would be which here, but let's say this is like a grade 9 reason, so or grade 8 reason actually, so that will probably be 1 mark for A1 and for the reason. Then this one, perhaps maybe that one will be 2, that one will be 2 because this is a grade 11 reason, and then it will be 1 mark for that last statement because alt angles also is a grade 8 reason. I know that angles opposite equal sides is as well, but this is a reason that a lot of people get wrong. So I think they'll probably give 1 mark if you're getting B, but then you'll lose the mark if that reason is wrong. Okay, so 6 marks for that. And guys, we actually got all of this information. We got all of these angles in our session of going through this paragraph. Okay, next up, 9.2.2. Let me just move this up. Now, this is an interesting question, all right? They are now saying, prove that ABPR is a cyclic quad. ABPR. Now, guys, ABPR is not even drawn in at the moment. What I'm going to do is I'm going to erase this highlighter. Let's just take that away there. Let's make it a bit bigger so that I can actually highlight this the cyclic quad that they want us to work with now. All right, so they're saying A, B, P, and then R. All right, they're saying that that is the cyclic quad. We need to prove that that is a cyclic quad. Now, guys, like I said, this is difficult because firstly, they didn't actually draw it in. All right, that's the first thing. So we need to realize that BP would be one of the sides of that quad. And the other thing is that they haven't drawn a circle through these 4 points. So it's quite difficult to visualize that. Now, guys, there are 3 ways in which you can prove that a quad is cyclic. Remember, a quad is cyclic if, not only if there is currently a circle going through the 4 points, but if you could draw a circle going through the 4 points. Now, guys, you can't just take a pencil and like try and do it and say, oh yeah, a circle fits through those 4 points, so it's a cyclic quad. These diagrams often are not drawn to scale, so you can't do that, unfortunately. There are 3 other ways in which you can prove that something is a cyclic quad. All right, so I'm going to list them for you. Feel free to copy them down if you want. The first way, where shall I write this? I'll write it just underneath. 3 ways of proving that a quad is cyclic. Okay, the first method, which many people think is the easiest one, is to prove that one pair of opposite angles add up to 180 degrees. All right, that's the first thing. So if you can, for example, get the one angle, then get the angle that's opposite that. If you add them together, they add up to 180. Then you can say that it's a cyclic quad. And the reason that you will then write for that is converse op angles of cyclic quad. All right, that's one method. The second method is to prove that an exterior angle, and I'm saying an exterior angle because there are lots of different exterior angles that you could have. It would depend on the diagram. So prove that an exterior angle is equal to the opposite interior angle, because we know that that is a property of a cyclic quad, that the exterior angle is equal to the opposite interior angle. So if you can prove that, right? If you have, let's say I have A4, all right, I'm just using this as an example. A4 would be an exterior angle of this quad, and I can then prove that A4 angle at P, then I can say, okay, A4 is equal to RPB, which we don't know in this case, right? Because we don't know what that angle is. That angle wasn't given at all. So if we could prove that, if we could say that A4 is equal to this angle here, then we could say that it's a cyclic quad because it has one of the properties of a cyclic quad. All right, so then we would say our reason would be converse exterior angle of cyclic quad. Guys, you have to have the word converse there. If the word converse is not there, you don't get your reason mark. Okay, that's very important. So let me highlight converse and converse here. That is so important that you have that word there. And now the third method, which is the most difficult method, and it's also coincidentally the method that we have to use in this question, is that you are going to prove that angles in same segment works. All right, so you're going to prove that a chord, now a chord is going to be a side of the quad. I'll explain now when we go back up to the picture. So prove that a chord subtends equal angles at the circumference. All right, and this is a bit more difficult to see, but like I said, I'll show you now. My tan chord theorem reason, because that's not converse tan chord, that's just tan chord saying that this angle is equal to that angle. You only use converse tan chord if you are proving that a line is a tangent. So we did that in yesterday's live. So if you want to see how that works, you can go watch yesterday's live recording. But if you're using tan chord theorem just to say that these two angles are equal, even if it's coming from the inner angle to the outer angle, it's still tan chord theorem. It's not converse. Okay, converse is only when you are using tan chord to prove that it's a tangent. Okay, tan chord theorem, it can work from this angle to that one or from the inner angle to the outer chord. Then you just always say tan chord theorem. You're welcome. That's a very common misconception. So thank you for asking that question. All right. So prove that a chord subtends equal angles at the circumference. And for this, you will say converse angles in same segment. Now, guys, this is the difficult one to see because we don't necessarily, we don't necessarily think of angles in same segment when we're thinking of a cyclic quad. I think these first two are easy to understand because if you are trying to prove that something is a cyclic quad, you need to prove one of its properties, right? You need to prove either that one pair of opposite angles add up to 180 because that's a property of a cyclic quad, or you need to prove that an exterior angle is equal to the opposite interior angle because that, again, is a property of a cyclic quad. This one, the third one, relies more on what is a cyclic quad actually? So I'm going to go back up to the diagram, and this is a difficult concept, guys, so I need you to listen carefully. A cyclic quad is a quad, right? So a shape with four sides that a circle can go through, all right? So a circle can go through all four of these points. Now, guys, if a circle is going through point A and point B, right? Then that means that AB is going to be a chord of that circle. Because if A and B are on the circumference of a circle, now I'm not looking at this circle, all right? This is an imaginary circle. This is a circle that we can't see. It's not drawn in. If the circle is going through points A and B, that means that A and B lie on the circumference of that circle, so AB is a chord. At the same time, if the circle is going through P as well, BP is also a chord. If the circle is also going through R, PR is also a chord, and then it's going back through A, so AR is another chord. All right, I'll see if I can draw it now. It's a bit big, so it might overlap, but I'll see. So here, what we need to understand is that if they're asking us to prove that this is a cyclic quad, we need to think of all four of these sides as chords of the circle. Now, guys, if you have a circle, right? We all know how angles in same segment works. If you have a circle, let me do a circle here. I'll just do one on the side. If we have a circle, there we go, and we have a chord in the circle, then we know that this chord subtends equal angles at the circumference of the circle. All right, so I'm just doing a very rough sketch. Oh, there we go. Just doing a little sketch there. All right, we know that these two angles are going to be equal. Sorry, let me go back into pen mode. We know that that angle is going to be equal to that angle because of angles in same segment, right? Now, if we are taking this circle out of the mix, and I'm telling you that this line, right, subtends, or this line has, oh, sorry, I knocked my cover. This line has two angles at that point and at that point that are equal to each other. Guys, the only way for that to happen is if that line is a chord, that angle is at the circumference of a circle, and that angle is at the circumference of a circle as well. Right? That is how angles in same segment works. Remember, angles in same segment are only equal if it's a chord. So it has to go from a point on the circumference to another point on the circumference, then subtends those angles at the circumference of the circle as well. So that point has to lie on the circumference and that point has to lie on the circumference. So if we can prove that that is happening, right? If I'm now taking away the circle, let me just try and do that carefully. Oh, there we go, I messed up. Okay, just do that. If they've given us this diagram and they're asking me, prove that, and I'm just filling this in, this obviously isn't drawn to scale or in the correct orientation at all, but prove that ABPR is a cyclic quad. One chord of this quad is subtending equal angles. So the only way for that to happen is if that is a chord, so these 2 points lie on the circumference, and those 2 points are on the circumference as well. And that is where converse angles in same segment comes from. So let's look back at the diagram that we have, right? I want us to look at chord AR. Do we see that chord? Chord AR. Now I'm hoping that we can notice that from chord AR, we have an angle at B that is equal to X, right? Do you see that shape there? That shape there going to B, all right? So from chord AR, we have an angle to B that is equal to X. We have an angle at P that is also equal to X, right? Do we see that? So guys, that is where the whole angles in same segment thing comes in. We have a line that is subtending equal angles. The only way for that to happen is if that line is a chord of a circle. So remember, for a line to be a chord, the 2 points have to lie on the circumference, and for that chord to then subtend equal angles, those two angles also have to be on the circumference of the circle. So point B also has to be on the circumference and point P has to be on the circumference. So if we have understood that all four of these points have to lie on the circumference, isn't that what a cyclic quad is? A cyclic quad is a quad with all 4 points on the circumference of a circle. All right, so that was a complicated explanation now. You might need to just Make sense of that in your mind a little bit. I did explain this in a video lesson on my YouTube from last year. So if you go to my YouTube grade 11 playlists, there is a playlist on Euclidean circle geometry, and there is a lesson where I explain this in detail again. So if you would like to listen to that explanation again, feel free to go do that, but I will also post this on my YouTube later on. Okay, so guys, that is how we're going to prove this one. We're going to say angle ABR is equal to angle APR, right? They're both equal to X. We figured that out in the first question. Therefore, ABPR is a cyclic quad, and the reason is going to be converse angles in same segment. Okay, let me write that down. What were those angles again? ABR and APR. Right, angle ABR. Sorry, let me just zoom in a bit, and that's actually a bit big. ABR. That was a terrible R. Okay, ABR is equal to A. Oh dear, why am I making so many mistakes? APR. Right, you can say they're equal to X. You don't have to. It was proven in the previous question already. ABR equals APR equals X. Oh, wait, we don't put the reason there. Therefore, ABPR is a cyclic quad. And the reason is converse angles in same segment. Make sense of that in your mind. Yeah, those who can't do, teach. Mia, I feel like that's unnecessarily rude. What I meant by that statement is that maybe you just need some time to work through this, to understand this. I think I explained that quite well. If you don't think so, then you are welcome to leave. Actually, let me do that for us. Cheers. All right. So guys, that was quite hectic, that last little bit, but that was a long explanation. I thought that it would be good if I explained that in detail because it is a difficult concept. It doesn't come up very often, so I think maybe you will probably have more experience in 1 and 2, but maybe not in number 3. All right. Let's look at the next question. Now, this is from the November 2020 exam paper, so not last year's one, but the one before. Thank you, Abdudayan, and it's nice to see you here again. You helped me so nicely with the nerdle the other day. Okay, November 2020. Sorry, I just need to drink some water quickly. Okay. I do remember you, yes. Okay, November 2020. Let's take a look. Question 8. Now, guys, also what I've noticed is that usually with these circle geometry questions, the first question is usually just a number question, right? So a question that works with numbers only. And then the next question is usually one with variables. And they often have those like prove that this is a cyclic quad, prove that this is a tangent, those types of questions in the second part. Okay. Please give us a bathroom break. Okay, run quickly. I will just take I'll take some more sips of my water. Everyone can read through this quickly. Let me just drink some more water. All this talking is giving me a what's the word? A sore throat, a dry throat. Of course you can go to the bathroom anytime. Maybe everyone should get up and take a little stretch. 15-second stretch. Let's all do that. Okay, let's get back to it, guys. I want to get as much done as possible. We have 15 minutes left, then I'm going to have to sign off. because I have an appointment. Okay, question 8. O is the center of the circle. Wonderful. I prefer that to an M. Okay, O is the center of the circle. That's lovely. They've given us O. Now, guys, I'm hoping that we notice here, it's quite a good thing also when you are... I'm glad to hear that you at least understand me. That was quite a rude comment earlier. Sure, I don't like it when people are rude. Okay. Anyway, I'm speaking to the nice people on this live only. Okay, so when they have radii, when they're telling us that something is the center, right? It's quite a good idea to actually identify which lines are actually radii here, because that can help us later on. So OK is a radius, right? So let's put a little line there. OP is also a radius, so I'm going to put a little line there. And ON is also a radius. OM is not a radius. Okay. How many days a week do I go live? So I don't really have a lot of time to go live in the week when school is on, because I have sport 4 days a week. So I try and make some time here and there. But if you follow me, then you will be notified when I go live. I'm going to try and go live more in the second term, because I do know that it's an exam term. So yeah, hopefully I can do that. So I don't have what's the word? I don't have like a set schedule at the moment, but I'm working on it. Okay, let's see. Determine giving... sorry. Let's read through the whole thing. My apologies. KOM, okay, which is this line, bisects chord LN. Okay, that's interesting. Sorry, let me actually just fix these lines. They've already used one line here, so we can't use one line on these, because hopefully we understand that... There we go. That LM and MN are not necessarily equal to these ones. Okay. So KOM bisects chord LN, and MNO, this angle here, is 26 degrees. Okay, they filled that in on the diagram. K and P are points on the circle. K and P, we can see that, with angle NKP equal to 32. NKP equal to 32 degrees. OP is drawn. Okay, lovely. Determine, giving reasons, the size of O2. Now, guys, O2 is an angle at the circumference, at the center, is an angle at the center. Let's see, what is this angle subtended by? Which arc is subtending this angle? Arc PN, right? So PN subtends this angle, O2. Does PN subtend another angle? Hopefully we can see that PN subtends K1 as well, all right? So PN subtends O2, but also K1. Now we know that when an angle is at the center, it's double an angle at the circumference. So K1 is 32. That means that O2 is going to be 2 times 32. I think I did see someone putting it on in the comments already. Sorry, I didn't catch your name. So O2 is going to be 2 times 32. Okay, let me just erase that. So O2, I'm actually just going to write it down here to save some space, is going to be 2 times 32, which is 64 degrees. And the reason for that is angle at center equals 2 times angle at circumference. And I know this is a very long reason. Unfortunately, we do have to write the whole thing down. Okay, yes, 64 degrees. Cool, that's an easy 2 marks, right? So that would be 1 mark for 64. Oh, that's an ugly tick. 1 mark for 64 degrees and 1 mark for the reason. Okay. Let's look at the next one. For B, they're asking us to find the size of angle O1. Now, guys, if you look at the mark allocation, O1 is a 4-mark question. So that means that it's going to have more steps than the previous one, all right? That's also quite a nice thing to look at. If you can look at the mark allocation, that's a good guidance as to how much you need to write. And, yeah, just especially in reference to or compared to the previous question. The previous question was a 2-mark question. It was 1 answer and 1 reason. So we're probably going to have to use maybe 2 values, 2 reasons, something like that in this one. Okay, so now we need to find O1, which is this angle over here. Now, guys, we know that O2 is 64 degrees. Let me just fill that one in over there. Okay, O2 is 64. We have a 32-degree angle over there. Do we have any ideas? How can we find the size of angle O1? We see that O1 is subtended by KP, also at the center. Is there any other angle subtended by KP? No, not that I can see. All right, so we won't be able to use that. What do you guys think? I'm looking at the comments. Something that we didn't look at earlier is that, do we remember that theorem? I think it's theorem 2, right? Theorem 1 says that if you have a line from the center of a circle, right, that is perpendicular to a chord, it bisects the chord. Theorem 2 says if you have a line from the center of the circle that bisects the chord, then it is also perpendicular to the chord. So M2 is 90. Maybe that helps us. M2 is 90. Okay, so we can get O3 from that. Yes, absolutely. Wamiani, yes. We can get O3 using interior angles in a triangle. I always say angle sum in triangle, but it's the same thing. And then we have angles on a straight line. Perfect. All right. Let's do that, guys. Well done. Okay, so we're going to say that angle M2 is equal to 90 degrees. Now, guys, this reason is maybe one that you can't remember because it's not one that we use often. All right, but it is line from center to midpoint of chord, because that's what they gave us, right? They gave us a line from the center, OM, and because it's bisecting this one, M is the midpoint of this chord. Okay, so line from center to midpoint of chord, that's 90. So then O3 is equal to 180 minus 90 minus 26 degrees. The reason for that is angle sum in triangle. All right, so 180 minus 90 is 90, minus 26, so 90 minus 20 is 70, minus 6 is 64 degrees. All right, so O3 is also 64, is that correct? 90, that's here, okay. So therefore, O1 is going to be, if we're using angles on a straight line, 180 minus 64 minus another 64. Angles on a straight line. I suspect that there was a quicker way of doing this because this looks like it's one step more than what would be worth 4 marks, but maybe they would give only 1 mark for that. 1 mark for the 90, 1 mark for, oh yeah, probably 1 mark for that, 1 mark for that reason because that's a grade 11 reason, 1 mark for the 64 and this reason, and then 1 mark for the 01 and the reason. Okay, so what is this? 180 minus 64 minus 64. That's 180 minus 128. Is that 52? Yes. KON is 50. KON is 90. KON is 90. This one, no, do you mean KMN? KMN is 90, yes, which is M2. What's happening? Why are you shouting at me? 52 degrees. Thank you, Abdudayan. Yes, there we go. Okay, so O1 is 52 degrees. All right. Like I said, I'm sure there is a quicker way of doing it, but it's fine. Guys, the thing also about circle geometry and geometry in general, I don't want you to sit there for ages trying to find the shortest way of getting to an answer, right? If you see something that will work, like we did here, do it, okay? Instead of, I know, I teach AP Maths and sometimes I work with kids that are very clever and they want to look for methods that are only like 2 steps. They want to try and skip steps. They just want to, try and do it as quickly as possible. But don't waste time trying to find the quickest method. If you see a method that will work, go ahead and write it down. Okay, perfect. Let's see. Oh, Hannah, I'm so glad that you are enjoying this. All right. One last question. Prove. Let me actually just fill this in quickly because we found these values now. So let me fill in that O3 is also 64. It's a bit small, 64 degrees. And then O1 is 52. Okay, now they're saying, and here we go, guys. Here is a prove question, all right? Prove giving reasons. Oh, yeah, I know that Miss Martin's content is very similar to mine, yes. It is indeed. Prove giving reasons that Kn bisects OKP. Kn bisects OKP. Okay, so let's just make sure, what are they asking here? Prove giving reasons that Kn, this line, bisects OKP. So they're saying we need to prove that this line cuts this whole angle in half. So guys, we know that K1 is 32, so they want us to prove that K2 is also equal to 32. Okay, that is what they want us to do. Find K2, yes, and hopefully we can get that K2 is equal to 32 degrees. Okay, so let's take a look at what we have here. Now guys, this is quite nice because remember we filled in at the beginning that those two lines are equal because they're both radii, right? So here we have that OKP is an isosceles triangle. Now guys, if we have an isosceles triangle, we know that the angles opposite the sides, opposite the equal sides, are going to be equal. So angle K, K1 and K2 together, is going to be equal to angle P. I have the third angle in that triangle, so I can find what angle K, the whole angle K, is going to be equal to. And we actually did that yesterday as well, right? So we're going to say angle K is equal to 180 minus 52, and then that will give us this, right? If I say 180 minus 52, I'm going to get those two angles together. All right, and then because these two angles are equal, I can divide that by 2. Okay, let's see what we get for angle K, the whole angle K, K1 and K2 together. If we do it like that, so I'm going to write here K1 plus K2 is equal to 180 minus 52 degrees divided by 2. All right, let's see what that is. 180 minus 52 divided by 2 is what I thought it would be, yes, 64 degrees. Okay, so that means that this whole angle is 64 and this whole angle is also 64. We have a lot of 64-degree angles in this question. Interesting. All right, so I said 180 minus 52, that gives us that sum, and then I divided it by 2 because they're equal. So let's take a look. Yes, I see people are giving other options here. That's 100%. You can definitely use other options for this. Okay, so angle sum in triangle. That's why we said 180 minus. Then, how did I know that those two angles are equal? Because of angles opposite equal sides, right? It's an isosceles triangle. And also, how did I know that it was an isosceles triangle? They didn't actually tell us that, right? They didn't say that OK is equal to OP, but we know that they're both radii, so that is why they're equal. Okay, so you have to put in all 3 reasons if you're going to use this method. Very important. You usually get 1 mark for all 3 of these reasons. Okay, so please, if you're using this method specifically, make sure that you put all 3 reasons in there. Okay, then what are we trying to prove here, guys? We're trying to show that K2 is 32. Now, if the whole angle is 64 and K1 is 32, K2 also has to be 32, right? So therefore, K2 is equal to 64 minus 32. So K2 is also 32 degrees. I'll be there now. So therefore, K1 is equal to K2, right? They're both 32 degrees. So therefore, what were they asking us? The wording was a bit different. Kn bisects OKP, right? If these two angles are both the same value, that means that this line is cutting this big angle, the 64-degree angle, in half, if it's 32 and 32. All right, so we can say Kn bisects OKP. Okay. Awesome. Thank you, guys. I hope that that was helpful. I will try and go live again as soon as possible, but I'm going away tomorrow afternoon. I can maybe squeeze in a live tomorrow morning at some point, but I am going away tomorrow afternoon. Like I said, I will try to go live, and then yeah, if you follow me, you will get notified as soon as I go live. But if I decide to, I will make a live event in my profile. So you can just check maybe tomorrow morning when you get up, just check if there is an event there and then you can join. I'm not sure what time yet because I have some other errands to run, but I'm going to try my best to do that. Okay. I'm actually really enjoying working through these questions with you guys, and I really hope that it has been helpful. Thank you so much, guys. I'm just going to quickly scroll through the comments. Oh, sorry about that. Just see if I missed anything. I'm going to put the, aren't you supposed to give a reason for your answer? Not for that one there. It was just 64 minus 32 because we could see it on the diagram. Okay. Let's see. Actually, really nicely explained. You love geometry. I'm glad. That's great. Come check your hub. Here's someone saying, Miss Martins, Miss Angler, Miss Hanukum, what a trio. Why did I divide by 2? Because when I was finding this, I had this 52-degree angle, right? When I divided by 2 is when I was finding that angle K. All right, so when I do 180 minus 52, I'm finding both of these angles together, but since they're equal to each other, I can divide by 2. All right, cool. Thank you so much. Thanks, Abdudayan. Thank you, guys. Do I do grade 11 AP? I'm teaching grade 10 AP this year, but there are grade 11 AP notes on my Google Drive, so you can go take a look there. I'm actually not sure. I might have done absolute value. Yes, I did it with my kids, my previous class in grade 11. So there are notes on there that you can go take a look at. Okay, cool, guys. I have to run. I will see you soon and enjoy the rest of your day. Thank you so much for all the likes and the follows. And yeah, hopefully I will see you tomorrow. Bye.